Hey, good afternoon, everybody. Thank you to Prezi and thank you to IBM and to Infogram for inviting me and for putting on this conference. I've had so much fun meeting all of you, and this has just been an incredible time so far, but let's get started. So I just want to introduce myself a little bit. I started my studies at New York University and then studied computer science at the University of Maryland. Then for the last 2 years, I've been working in the Johns Hopkins Data Science Lab where, as I was introduced, have been working on educating data scientists, creating online courses, and also engaging with the alumni from our courses, which I'm going to talk about a little bit. I was also lucky enough to be on the faculty for a semester at the Penn School of Design, which is funny because you're like over here at the crunch side of things. What is this guy who's involved with design doing here? But for some reason, I have been having my feet in both of these communities, both design and data science and engineering and that kind of thing. And I just started my PhD 2 weeks ago at the University of California, San Diego, where I'm actually involved in a group there called the Design Lab, even though many of the people there concentrate on designing tools for data scientists and on perfecting the data science process and experience. So we're going to be talking about data science a lot over the next couple minutes, and so I want to define exactly what I mean when I'm talking about data science. This is not I'm not saying necessarily that this is the correct definition, it's just what I mean in terms of this presentation at least. So when I talk about data science, I am referring specifically to this process where there is some data out there in the world or maybe some observations that you'd like to collect or observe, and so you import that data into your computational environment. Maybe it's in a database, maybe it's in a CSV, somehow you get a hold of it, and then you tidy that data. So what that means is that you get the data into some kind of form where it's easy for you to think about or it's easy for you to work with in whatever computational environment you're working in. And then you kind of go around in this cycle where you're transforming the data more to explore it. Maybe you're creating some graphs and some other visualizations in order to see what's going on in your data set, and then you might build some models to try to understand clusters in your data set or how variables in your data relate to each other and how they affect each other. And eventually you go on through this process and hopefully you come up with some inferences. So hopefully you are able to see that there are some patterns or that maybe some variables are affecting others. And ultimately it comes down to making some decisions where either you communicate the results from this process or perhaps you're more interested in creating programs that give out reports that folks can read and interpret on a regular basis, and therefore you're automating this process. So that's what I mean by data science. Now I want to introduce some of my collaborators. So this is the team right now at the Johns Hopkins Data Science Lab, and just to let you know, all of the materials I'm going to talk about and the projects we've been working on, you can see at jhudatascience.org. But really the three musketeers of this project, as they're known, Jeff Leake is a genomic scientist in the Johns Hopkins Bloomberg School of Public Health. Roger Peng is an epidemiological and environmental data scientist, and Brian Caffo works with brain imaging data and more of a neurological type of data. And the courses that I'm going to be talking about are all available through this platform called Coursera.org. Has anyone in the audience heard of Coursera? Would you mind raising your hand? Oh, okay, great. So a good number of you. We have 3 offerings on Coursera right now, and later on towards the end of this talk, I'm going to talk about a rumored 4th offering that's coming up. But the first one and probably the most famous one is our data science specialization, where we have actually had 4 million people enroll over the course of the last 4 years, which is unbelievable, and I'll get into that story a little bit, of course. Then we have the executive data science specialization, which is a great hands-on experience for managers of data scientists and for folks who work with data scientists. And then we have the mastering software development in R specialization, which is this specialization that was designed to bridge the gap between data engineers and data scientists. So if perhaps you're a data engineer who's more interested in analysis, or you're a data scientist who's more interested in database structure and management, we kind of identified that center part as a market and designed that specialization around those folks looking for those kinds of offerings. So first I want to talk about the data science specialization, the most well-known of our programs. Oh, and one thing that I do want to say before we launch into this is that if there's nothing else that you remember from this talk and everything that I say is totally incoherent to you, please, if you take any one thing away from this talk, is to go find this Practical Data Science for Stats collection of papers that was recently published on this website called PeerJ. I know that a lot of the folks in this audience are not from academia, which is kind of where I come from, but even if you're not used to reading the academic literature, it's practical data science, so what's written in here is extraordinarily practical advice that I think is really salient and clear and can help people with a lot of their data scientific workflows. I'm allowed to say this because I'm the author of one of the papers in this collection, which this talk is loosely based on, and I would say that my paper is like somewhere in the middle of the ranking of all these papers. Four that I can recommend more highly than mine is this paper, Forecasting at Scale, by Sean Taylor and Benjamin Leatham, and they're from Facebook. Another thing that you'll find out if you go look at this collection is that a lot of the papers are written by people who work in corporations, just to give you an idea of who these papers are for, who their audience is, in other words, the business community. How to Share Data for Collaboration by Shannon Ellis and Jeff Leake. Opinionated Analysis Development, which I really love, by Hillary Parker at Stitch Fix, and I know that we had Cassandra talking from Stitch Fix yesterday. And Data Organization in Spreadsheets, something that I get really excited about, by Carl Broman and Kara Wu out of the University of Wisconsin, and a fantastic data science education startup called DataCamp. So now to get started with the data science specialization story. One day, Jeff and Roger and Brian, back when the MOOC and online learning revolution was really getting started in like 2011, in 2012, they had been teaching these courses at Johns Hopkins for years, and they said to themselves, well, what if we put this content online, and that will at least help us teach our courses, where we can have students watch videos and do assignments at home, and then when they come into class, we can really get into the nitty-gritty of doing this kind of data scientific work. We can augment our classes that way. So, you know, I have an unbelievable email from Roger that says, can you imagine if we had like 5,000 people take our course, how amazing that would be? And what happened really just blew everyone away, where we had hundreds of thousands of people enrolling. You know, in one of the courses, the Computing for Data Analysis course, which is really an intensive R programming course, we had over 20,000 people actually complete the course, which was like unheard of at the time. And that's when everyone felt like that we were really onto something here and that there was a need to be addressed. So we created the data science specialization, which is this series of 9 courses. First, we start off with the Data Scientist Toolbox, which gets folks up and started in their computational environment, and also teaches them like what data science even is and what we're going to be talking about in the rest of the course. This is actually a pretty important course because we have students from all over the world on different operating systems with different hardware, with all kinds of different computational resources available to them, and making sure that they're all on the same page before we get started is really important so that the rest of the specialization goes smoothly. Then we have the R programming course. For those of you who work in website optimization, this is the first sort of major falling off point in the course, where we take the students and we make them really competent R programmers, which of course is difficult, but we try to do it in the most humane possible way. Then we get into our getting and cleaning data course, which, going back to the data science Krebs cycle that I was talking about before, allows students to go out into the world and get their own data, or we also provide them with some data to work with, and then they can manipulate it into a form that they can work with later on. We then have an exploratory data analysis course, which teaches introductory graphing and making your own visualizations and customizing them so that you can communicate with your data. We then have a reproducible research course, which at first is definitely an important course for people who want to do robust science as far as creating sort of a methodology where they can reproduce their results and their data analysis so that other scientists can see that the work that they're doing is honest and that their analysis is scientifically relevant. But it's also important because if you're working in a company and you want to create reports that generate themselves continuously or in an automated fashion, it's the exact same skill set that's taught in that reproducible research course. We then have, now that we've drawn them in, we've got them 5 courses deep into the specialization, we kind of lay on the math in our statistical inference and regression models courses, which are both taught by Brian Caffo. And then we move them into the practical machine learning course. So now that they have this great mathematical foundation, we teach them how the most popular machine learning algorithms work, but unlike most machine learning courses that you might find in college, we have them, we just give them the algorithms so that they can start using it on real world data to answer questions. And then we finish up with our developing data products course, which teaches students how to actually make web applications based on the data analysis that they've been doing. And this is all within the R programming language, so it's kind of a uniting course to take everything that they've been learning and to be able to present it to other folks, and most importantly, to potential employers. So the enrollment for these courses really blew us away. The y-axis here is on the log scale. So as you can see, every month we had about 100,000 people enrolling, and then we had an order of magnitude fewer amount of people actually completing each course, but that's still pretty great considering that it was around 10,000 completers per month. And we think that the reason that we had so much success with this specialization was due to a couple key innovations, which I want to talk about, and then I'll synthesize into how those translated into things that our alumni were able to innovate with in the workplace. So the first thing, which is totally counterintuitive, is to give everything away for free. The way that we did that is, the way that Coursera works is that you can pay for each course in order to get a certificate, but you don't necessarily have to. You can audit the course and all of our content is on there for free. We very heavily utilized GitHub, so all of our course content is available on GitHub. And we also teach GitHub in the course so that if students found a mistake or they wanted to add something, they were welcome and open to do that through the pull request system, if you're familiar with how GitHub works. And then we took big advantage of this website called LeanPub, which a lot of people aren't familiar with. But basically what it allows you to do is that you can write books in plain text, which if you do data science work or you write code, you probably are doing a lot of work in plain text as it is. And so it just plugs really well into regular data science workflows, and all of a sudden you're taking content that you would have produced for a personal blog or for your workplace or whatever, and in that same workflow you end up writing books. And so this method was like unbelievably productive for us. The 4 of us in 3 years wrote 15 books, and I wrote one of these books and co-authored 2 of them. And that's on top of all of our other responsibilities at work and all of the teaching and research responsibilities that professors have. And so this was just an unbelievable productivity hack for us. Another great innovation was that we wanted to give real-world data to the students in our specialization. And so we partnered with 2 companies. One of them is this company called SwiftKey, which if you're used to using a keyboard on a smartphone when you're texting or writing an email, maybe some of you have these kinds of keyboards where instead of lifting your finger up every time to click on an individual key, you just swipe your finger over the keys of the word that you're trying to say, and it basically intelligently guesses what word you're swiping out. So SwiftKey is one of the companies that developed that technology, so we partnered with them in order to obtain real-world data sets of what paths over the keyboard users were swiping, and then to use that data to try to guess what words they meant. And then we also partnered with Yelp. Yelp does a lot of great integrations and partnerships with educational institutions to make their data available about all of the restaurants and venues and data that they have about the places that they review. And our goal here was that our students could take the skills that we had taught them in the data science specialization. They could use our reproducible research in developing data products course to present a data product to employers that they built with real-world data that they could say, hey, this is an example of exactly the kind of work that I can do for you if you hire me. Another key innovation, and anyone here in marketing probably knows this, which is that people love consistent content that is delivered in a timely fashion. And so we were the first on the Coursera platform to run every course every single month. How it used to work was that it was on a semester system as if you were enrolled in a real university, but it happened to be online. And so by making sure that every course was run every single month, you could easily drop out of a course if you didn't have time, pick up a new course when you did have time, and never really lose your place. And also it kept things very fast-paced so that people could finish the entire specialization in a timely manner if they were able to. Another really important part of the program was that we integrated the content in the specialization. So what a lot of traditional academic data science programs look like is the statistics department comes together with the computer science department. They throw together some of their courses and they say, oh, look, now we have a data science program. So that's absolutely not what we did. We made sure that at the end of every course there was a direct handoff to the beginning of the next course, and that way there was some coherence in how a student progressed along throughout each of the courses. And I just want to point out that one traditional academic institution that I think is doing this really well is the University of British Columbia. They just launched their data science master's program, and it's a testament to the sophistication of the program that their website with all of their curriculum and with the courses is on GitHub, so you can visit there if you want to check it out. And then another important part of the specialization was this piece of software that I spent a lot of time working on and continue to maintain, which is called swirl. Originally, it stood for Statistics with Interactive R Learning, but essentially how it works is that if you do programming work and you're familiar with either a Python console or an R console or maybe just your regular command line, it transforms the R console into an interactive experience. So you open up Swirl and you start up the Swirl program in your R console, and the console starts talking to you. You can go through courses and lessons that instruct you about what to type in to the console, what it is that you're doing. You can answer multiple choice questions. You can also write scripts and different smaller pieces of software, and Swirl will evaluate their correctness. Swirl is totally open source software, and anyone can create courses for Swirl, but we took a big advantage of Swirl in every programming heavy course in the specialization so that we knew that students were getting that kind of experience actually writing as much code as they could and having Swirl as a guide to take them through the process of learning how to code. So some lessons that I want to share from the data science specialization that we have come to know through interacting with our alumni is that data scientists really want to create online artifacts, and a lot of them believe that this is a really fundamental part of their job and kind of their identity as data scientists. And if you want an example of the kinds of online artifacts I'm talking about, Stitch Fix and Stack Overflow both have wonderful technical blogs that are written by their data scientists and their software engineers that allow them to showcase the kind of projects that they've been working on. Also, a lot of corporations write their own and maintain their own open source software that they share with other folks. And a great example of that is this Profit library, which you can use for basic, like off-the-shelf forecasting of trends and sales and those kinds of time series data, and that is from Facebook. So we also learned that data scientists want to be able to do in-house data science training. We've gotten a lot of great feedback about folks using our materials within their corporations or within their companies to do data science training, and we're really interested, I'm particularly interested in how to make those trainings more enriching. So if that's something you want to talk about, I'd be happy to talk after this presentation. And domain expertise is an extraordinarily important part of data science. So essentially, you can have all of these great reporting and data cleaning and modeling mechanisms set up, but there has to be a fundamental understanding of your business or of your science or whatever it is that you're using your data analytic process for. But buy-in from management is also important in this process. So what I mean by this is that if you have a data science team in your company and they come to you with some inference or some analysis, and then you do the exact opposite of what that inference says or what that analysis says to do, and you do that enough times, it's very demoralizing. And so I think that that's sort of an important part of the management science of data science that we've learned in this experience. So next I want to talk about the executive data science specialization just for a little bit, basically as a preview of how it works. And so there wouldn't be a data science talk, like you thought that maybe you could make it through this conference without seeing this headline, but I think it's actually very funny how this headline from the Harvard Business Review now 5 years ago has played out over the, over the last 5 years. And other interesting headlines that are kind of related to this is how companies are going around trying to structure these internal data science boot camps in order to train more data scientists through their recruiting or in order to transition software engineers that they have already in-house into more data science type roles. And so it's obvious from this that management is very interested in how data scientists work, how to work with them, and how to get the most out of their data science teams. So what we did was we partnered with a company called Zillow, which if you're not familiar with Zillow, I don't know what their operations are outside the United States, but what they do is they offer, they're a real estate website where you can go and find out the prices of homes on the market and also the prices of apartment buildings and so forth. But Zillow has this great product that they call the Zestimate, which if you're the owner of a home or you would like to rent your home, you can go onto Zillow and Zillow will basically create a prediction for you of how much your home should be worth based on market data. So we partnered with Zillow to make this immersive, interactive experience for folks who are managing data science. So for example, this is an example email in this DataCamp platform, which I mentioned a little bit earlier, where folks who are training in our specialization to manage data scientists receive emails, they watch videos, which are supposed to be like simulated conversations with data scientists, and then they make decisions based on the emails they receive, which have attachments that contain presentations and graphs and analyses, plus what they learn from the data scientists in these conversations, and based on whether or not they're making the correct decisions to lead their business, or to lead Zillow specifically, so you're kind of play acting as a data science manager at Zillow. Depending on how many correct decisions you make or incorrect decisions you make that impacts your grade in this specialization. So this is just another slide of like modeling considerations that a data science manager would need to be aware of. And a lot of these observations and best practices are available in this executive data science book, which was written by Roger and Brian and Jeff. So some lessons that we learned from that specialization were that data science technologies tend to trickle up. This is important if you're a manager of data science, if you're a manager of data scientists, so that you know kind of what the most cutting edge technology is that you should pay attention to and ask what your data scientists are using, because they tend to be the ones who are on the right technical blogs and following the trends and seeing what technologies are out there that are getting traction. And it's especially good to know if you develop any of these data science technologies. So if you're doing marketing and you're trying to get folks to use whatever platform you're developing, I highly recommend, at least in our experiencing, targeting the actual data scientists seems to be very effective. If you're, as a manager, it's often a concern that we hear all the time is, oh, like if I only understood more of how software engineering works, maybe I would understand this part of the process better, or if I only understood more about mathematics or statistics, then maybe I could work better with the data scientists that I manage. And in our experience, at least, my recommendation, or our collective recommendation, is that it's probably better to know more about basic statistics rather than basic programming if you have precious time and you're choosing between the two. Data scientists are making their inferences and their recommendations at the end of some kind of analytic process that usually involves a statistical method. So if you understand the methods that they're using and the way that they're quantifying uncertainty, then you have a better chance of understanding their thought process than if you learn to code Python or something, if that's not something that you have experience with. And so finally, from this specialization, we learned that developing a data analysis, especially an analysis that gets repeated over time based on reporting or based on a certain KPI that you're trying to, that you need to know every so often, you should expect the development of that process to look a lot like software development. So in the same ways as that things need to be test-driven and that software development often takes a lot more time than folks expect it to, we find that the same is true in this process of analysis development. So finally, I just want to talk a little bit about mastering software development in R, this last specialization. And so classically, there's like this data engineering role where folks are setting up databases and maintaining them and are making sure that they're behaving well, and obviously are making sure that they're interacting with whatever platform that's usually online. And then there is this totally other role of the data scientist who is taking some metrics, taking some measurements, and trying to come up with decisions and inferences and to try to analyze patterns. But we have identified over the last couple of years that there is a role that is emerging in the middle of this duality. I think that someone or two people really, whose job is like really at the center of this is, if you're familiar with David Robinson and Julia Silgi at Stack Overflow, which is a really popular website for programmers who are trying to get help and advice when they run into programming issues. They're both technically data scientists at Stack Overflow, but they live really close to the data engineers at Stack Overflow so that they can have access and have ownership over the data that's going into those databases that the users are generating. And so in identifying this kind of new kind of data science programmer or data science software engineer, we created this specialization called Mastering Software Development in R, which I wrote with Roger and Brooke Anderson, who's another professor. And the few things that we have learned in this specialization, which hasn't been around as long, but we still learned that the field of data science is still taking form. So there are still these roles that are coming up that people didn't expect that are helping to define what the field is. And therefore, experimentation with those roles might be able to give you a competitive advantage. So if a data scientist comes to you, if you're a manager of data scientists, and they say, hey, this is a project that I really want to work on, or maybe it's something less traditional or not a way that you think of a data scientist, you never know. This might be a new kind of work and a new kind of position that if somebody is having the insight to create those kinds of projects for themselves, that might be giving you a leg up against competitors. And also, taking risks is a lot easier if you're a part of a community. And I think that I mean that message for people who are actually doing data science work. So in other words, to get out there and to write and to attend events like this, and to see what's going on, to make sure that ideas that you have for your company or for your role make sense. So nobody has discussed this before in any setting that I'm aware of, but we're working on a new specialization. I don't think that it's super hard to guess what kind of specialization we're working on. It's a very popular computing-intensive field. We're unsure what kind of success that we're going to have, of course, but in terms of the wholeness and really the absolute, sorry about this, how complete the content is going to be of this course, we would like that to match the data science specialization. So there's already one course out right now that you can take on Coursera, which will be a part of this specialization. It's called the Unix Workbench. This is going to be a very computationally intensive specialization, and so this is probably going to be the first or second course in this specialization in order to introduce people to using the command line, which is a really powerful and direct way of manipulating computers. And so the book is online, the course is free, the book is part of this pay-what-you-want model that LeanPub does, which free is part of that spectrum. And so I encourage you to go check it out. And I wrote the course and wrote the book, so if you have any questions about it, that's something I'd be really happy to talk about. And that's what's going on at the Johns Hopkins Data Science Lab. Thank you so much. This has been a lot of fun.
Thank you so much, Sean. Okay, so let's see if we've got any questions for you. And we have, so let's shimmy on over here. So I'm going to get you to come a little further. They want to see you. They want to see you.
Yeah.
Okay, so which course do you recommend for getting started with deep data? Is that worth that phrase again?
Yeah, I'm really interested in what folks mean by deep data. If you are referring to deep learning and neural networks, which is what I would think from that phrase, right now the best thing out there, in my opinion, is this course called fast.ai, and that's actually the URL for the course also. And it's free as far as I know. And as far as what's on my radar, that's what I recommend.
It's like we launched deep data at
this
conference.
Great job. Yeah, I know.
Okay, so how do you envision the management of deep data, here we go, good gracious, in the future strategy of Coursera?
Okay, so the first thing is that I cannot speak about what Coursera is going to do or not do. I actually have no idea what they're going to do or not do, so it's not because I'm not allowed to, I just don't know. The management. Okay, so right now, so Coursera actually launched this course written by Andrew Ng, who's one of the founders of Coursera, about deep learning. And I think that course, it's very math intensive. If you like calculus and partial differential equations, and that's your jam, then that is a wonderful place to start. And the way that he lays it out is great if you're mathematically inclined that way. I don't know what other universities or organizations are building for the Coursera platform. I guess I partially answered this question in what I didn't announce but teased. So I'll leave it at that.
Okay, so this is a question that's been literally asked almost to every speaker. Somehow deep data is in it, but I'm going to go back to it, which is the question regarding, can you recommend any resources for keeping up to date, are you ready for this, with the latest trends and topics in data science, such as AI, deep data, etc.?
Sure, so someone actually asked me a similar question, which is like, is there a data-driven way to keep up with who to keep up with? And I don't have a good answer for that, but I really love Twitter, and there's a wonderful data science and R and Python programming community on Twitter, and two accounts that I really like is Renee Tate, who's, I think her Twitter handle is Becoming Data Sci, and actually, if you can put my laptop back up, I can show them, but maybe I'll do that at the end here or something. And then also Mara Averick, who I think that her Twitter handle is Data and Me. Both of them are like unbelievably great curators of these kinds of resources, and they are my go-to for this kind of question. Yeah.
Okay, great. So, so I'm going to leave the next question. I'm going to go to the one below.
Okay.
Because I think if I say deep data again, everyone may just die.
Sure.
Okay. So, did you consider supporting also Python and Jupyter for course assignments?
Sure. And this actually, I think, kind of goes to what's being asked in the other question, which is the reason that we chose R is because it's the predominant language in the community that we are working in. So, meaning in genomic science and in the epidemiological sciences. And essentially, we had to make a decision about what we were going to teach, and R was what we were not only most familiar with, but like extremely intimate with. I mean, Dr. Peng's, his name is like written in the source code of R, so we really felt like members of that community and that we could best teach our students that way. Python and Jupyter are like Python is a wonderful language. Jupyter is an amazing project that has the most like unbelievable support and people behind it. And if you're passionate about Python and Jupyter, there are a lot of other offerings from other universities and organizations. And if that's what you're already familiar with, and you would feel more comfortable doing data science that way, then go for it and go for Python and Jupyter. Yeah.
Okay. So our final question for today. Our final question of this conference is R the best language to learn for, this thing is going again, DDS? There you go.
Man, I feel so honored that I was here like at the inception of whatever deep data science is going to be.
Yeah,
I know. Like, who knows?
I was there when it was born.
Yeah, exactly. Yeah, I know, right in the delivery room. But is R the best language? R is the best. I mean, I think that Python and R both have really unbelievably wonderful communities, just compared to like all other programming languages in general. The Python community is enormous because it's not just data science, it's web development, it's finance. There are so many like huge communities that are doing amazing things with Python, and there's so much written about it that it's really easy to get in and get started. The R community is kind of where I come from, and I know that there are dozens of wonderful folks who are working extremely hard every day to make it the main language for data science, and even going forward for like doing artificial intelligence analysis and type research. And so those are kind of the people that I know in the community that I'm most familiar with. But if you already know Python and you've been doing data science in a Python environment, it's hard for me to say that there's like a competitive advantage of one over the other. Python is more popular, as far as I know, by any like reasonable ability to measure. Although R has exploded in popularity, in the last 5 years, it's gone from like not ever even on programming language rankings to like in the top 10 or even more recently like in the top 5. I think like IEEE rated it as like the #6 programming language in the world, which is crazy to me, to someone who's been working in it as long as I have, that now it's that popular. And so Python has the competitive advantage of there probably being more people using it, and R.
I'm just clearing my throat.
Oh, sorry, okay. All right.
Get out.
I know, I thought you were giving me the cane, yeah, right.
No.
I would say that if there's one competitive advantage of R that I'm aware of, it's that the R community is I think, is farther ahead of the curve in terms of data products. So for example, there's this platform in R that's called R Markdown, which is an unbelievably easy to learn platform which allows you to create blog posts, academic papers, reports that you can automate, slide presentations, and even videos just from plain text and R code, and actually not just R code, but code from like a dozen programming languages, including Python and Bash and Ruby and JavaScript and all of those more popular languages.
Thank you so much.
Yeah, thanks so much.
Sean, we have, this is your picture. This is for you. It's a gift for you. We'd like to say thank you so much for being here. Thank you for sharing your knowledge and experience with us. And our conference has virtually come to an end. So thank you so much. Give him a clap.